Hello, my name is Scott Schenker, and on behalf of my 8 esteemed co-authors, I will be talking about a public option for the core. I want to start off by making some distinctions. There's technology, which is how routers and links are built, but we won't be talking about that. Then there's architecture, which we all know and love, layering, narrow ways, best effort. That came out of a lot of deep thought, and we as a community have spent a lot of time discussing clean slate alternatives. But that too is not the subject of this talk. Instead, I will be focusing on infrastructure, which is how the various entities arrange themselves to provide end-to-end internet service. This is the domain structure, how they peer, how you provide transit. And in contrast to the architecture, the infrastructure was not carefully planned, but is more an accident of history. And it has many problems, but we as a community have spent little time talking about alternatives. The paper presents one such alternative, and in this talk I will motivate it by discussing 3 problems. The first is the privatization of transit. Today, in contrast to the past, most traffic goes straight from the origin domain to the destination domain without any transit on the public internet. That doesn't mean that backbone bandwidth isn't being used, but it is mostly moved into private networks. These private networks aren't a bad thing, they enhance customer experience. But the question is, with these private networks flourishing, will the internet languish? Will it be left behind? Or will it still be able to provide high quality, low cost transit to all comers? The second problem is transitive peering. The classical peering relationships of customer, provider, peer are transitive. That is, my provider's provider acts like my provider. And BGP itself is transitive, and this strongly affects how money flows. But the flow of value is more complicated than that. Value is created and consumed at edges in terms of content and ads. And as Ferratine et al. Point out in their seminal paper, we really should think of this in terms of eyeball networks and content networks. The problem is that this lack of alignment between the flow of money and the flow of value leads to policy tussles. The most well-known policy tussle is that of network neutrality, which is our third problem. Network neutrality is a huge subject, but Henning has really crystallized it by observing that network neutrality is about money, not packets. And if it's about money, we should look to economics. And the economics of network neutrality is far from settled. The literature has many models, reaches many conclusions, and so there's very little clarity coming out of this literature. At the same time, the enforcement of network neutrality is a nightmare. The internet is obviously a global infrastructure, but network neutrality is controlled by a patchwork of local regulations. So what we need is both policy clarity, that is, we need an analysis that will tell us what's the right policy, and we need enforcement consistency. Once we've decided on a policy, how do we enforce it consistently in this global infrastructure? To address these problems, we propose a public option for the core, a POC. It is nothing more than a global nonprofit transit infrastructure. Initially, we imagine it based on leased bandwidth so that there's not a huge capital expense in the beginning. And last mile providers, or LMPs, would attach to it and use the POC for transit. These could either be new access providers or existing ones who decide to switch to the POC. There are other actors in the ecosystem, things like content and service providers who would attach either directly to the POC or to the LMP, and customers who would typically attach to a last mile provider. Now, POC changes the nature of the infrastructure. From traditional interdomain routing that you see in this diagram, everything above the dotted line is controlled by BGP. And you replace that with a much simpler flow where for the POC and the directly attached LMPs, there's no BGP, there's no transitive peering. Instead, you go from the source LMP to the POC to the destination LMP. And in deploying the POC, we imagine that it's deployed alongside the current internet. That is, the POC would be connected to one or more traditional ISPs, so it can start small and grow over time. And nothing changes for those who don't connect to the POC. To the rest of the internet, the POC just appears as another ISP. So this is not just a clean slate fantasy that requires us to change the internet overnight. Instead, it's an incrementally deployable proposal. So what benefits does it provide? Well, it addresses the three problems that I discussed earlier. It makes high-quality transit available to all last-mile providers and reduces the advantage of those with large private networks. It separates access from transit. Access is where value arises and consumed, where costs are huge. Transit by itself creates no value and the costs are decreasing. And by separating those two, it brings the flow of value and the flow of money into better alignment. And lastly, network neutrality regulations can be enforced through terms of service, so there's no need for international agreements on that. So there are two technical challenges that we discuss in the paper. The first is, how do you compensate bandwidth providers? That is, the people who are providing these leased links. You want to minimize the strategic behavior of these bandwidth providers so they don't spend all their time trying to outsmart each other. And the answer here is a strategy-proof auction that we describe in great detail in the paper. The second technical challenge is how to model the economic impact of network neutrality. And that involves first examining what network neutrality would mean in the context of the POC, and then analyzing whether it would be a good thing or a bad thing in this setting. So our findings here, we focus first on the very simple notion of network neutrality, that of termination fees. A termination fee is where a last mile provider will go to some content provider and say, you must pay me to reach my customers. Even though you're not directly connected to me, I'm not going to let your packets reach my customers unless you pay me directly. So it's obviously a gross violation of network neutrality, but it's simple to analyze. And what we can find is any level of termination fees reduces social welfare, that is the overall welfare of society. We also find that these termination fees favor incumbent LMPs and content providers over new entrants. So in this setting, network neutrality increases social welfare and increases competition. So given those benefits, you have to ask, could the POC become a reality? And here, the large CSPs who have these very large private networks, they could collectively provide an initial pilot. And you could see with that pilot how competitive it is with commercial alternatives. And if it starts attracting LMPs, it can take off from there. So you might ask, why would the CSPs do this? What would motivate them? And the answer is two words: fear and greed. Fear because the lack of network neutrality is a real threat to CSPs. If all of a sudden last mile providers can start violating network neutrality at will, that could cause real problems to the revenue stream. And greed, there's an adage in business that you should commoditize your complements. That is, if you have a product that requires two components, A and B, and you provide A, then you want B to be commoditized because that leaves more profits left over for you. Well, internet services require three components: a content or service provider, a last mile provider, and a transit provider. And the POC makes both transit and LMPs less expensive, leaving more profit over for the content providers. So to summarize quickly, the internet's infrastructure is really an accident of history. It wasn't carefully thought out and designed the way our architecture was. And that means that it has some problems. The POC helps address these problems by, one, making high-quality transit a commodity available to all, even if you don't have a large private network. It also aligns the money flow with the value flow, creating what we refer as the economic architecture of the internet. And it enforces network neutrality through its terms of service. And this might be more than just a pipe dream. We understand that this is a radical proposal, but it might actually happen because just like with network neutrality, the POC is more about money than about packets. And the content providers have very strong incentives to making this happen. And with that, I thank you for your attention.
Excellent, Scott. Thank you so much. A lot of great questions coming in. I'll start reading them off off of Slack. So Rachi Singh from UMass Amherst asks, how does the proposed economic architecture for the internet interact with pricing models from previous work that aim to solve similar challenges with net neutrality and fairness, in particular things like congestion pricing by Varian et al., customer-generated revenue and Nash peering, and other things that negotiate peering prices that directly benefit peers?
Okay, great. Great question. So I would say that congestion pricing actually is addressing a quite different problem in that it's trying to evaluate the externality that various flows place on other flows by causing congestion and assigning prices to flows. But that doesn't really talk about the flow of money for the network, which is sort of how domains compensate each other and so forth. And when I buy network service, am I buying, does that go recursively and so forth? So the variant proposal was really agnostic on that. The other proposal, the Nash peering, actually one of the co-authors on that paper is a co-author on this paper, and that was purely pairwise. That was saying that rather than when two domains compare the traffic rates, do they do this Nash bargaining solution? We're actually trying to put this into a larger context of all of the players of the internet as a whole. And for us, the Nash bargaining is really between a content provider and the last mile provider who is trying to do termination fees. And we're doing actually sort of straight, sort of typical service contracts between the directly interacting pieces, that is the last mile provider, the transit, and content. I don't know whether that addresses your question or not.
If not, Rachi, I'll ask you to follow up on Slack.
Great.
Seem to hit on point. Aaron Gember Jacobson from Colgate asks, how does POC compare to a nonprofit IXP? Is the fundamental difference that a POC is geographically distributed?
Yes, absolutely. We make this point very clearly in the paper that you can think of this as just sort of a global IXP. And it has many of the same properties, but I think by being global, its point is to try and transform the economics of the internet as a whole, as opposed to just being locally applicable. But absolutely, it borrows the concepts of an IXP and tries to expand them.
Sounds like that's the right way to think about it. James Salome asks, would a state with a POC have more control over quote unquote their internet? And how would a POC or POCs interact with international boundaries given funding?
So the way we've thought about this is that the POCs are like many ISPs, they're global infrastructures, and so we don't think of it as being bound to a particular country. And in fact, that was one of the points of by having the POCs terms of service be where you sort of enforce network neutrality, you're less reliant on the local regulatory infrastructure for enforcing those kinds of things. Now, that doesn't, we didn't talk about this issue just because we, can't address everything. If there were nation states that said, you must censor or whatever if you're going to have nodes in our country, how the POC responds to that is an open question, just like, it's open for networks today.
So last question, I'll pull off of the Zoom Q&A, so folks are welcome to ask questions there or Slack. Comes from Sergio Gutierrez, who asks, how would the interaction between CDNs and a POC be implemented? What does that relationship look like? Does the POC introduce further advantages or challenges in that use case?
So we talk about CDNs a little bit. They're obviously crucially important, and there are two things. The POC itself could support CDNs at its edge, or last mile providers can continue to support CDNs as they do today. The only requirement is that the network neutrality requirements would be that those CDNs would have to be offered on an open basis, meaning that there's a set price and for that price people can put their boxes in or their open CDNs rather than allowing particular content or service providers to have access and others not.
Excellent. Scott, thank you so much.
Thank you,
Thank you
everyone,
for
for
these
listening.
great questions. There's some more follow-on questions coming up in Slack, and Anya Feldman just brought up a really interesting point about IXPs as follow-on. So let's keep that conversation going.
Okay, thank you very much, Scott. I have a few questions. So we have an example of a nonprofit global network that's kind of stitched together, you know, Internet 2, Géant, Janet, Renater, all of the research and educational networks around the globe. How do you compare that with your proposal?
So I think that, you know, most of the nonprofits, at least in the US, connect sort of educational institutions and so forth. And that's really not getting at the fundamental commercial concerns, which is that we want to make sure that last mile providers don't have any leverage over content and service providers. And also that we want the global flow of money, at least. So in the US, these, you know, Internet 2 and so forth are really connecting sort of other educational or research institutions. And so they're really not addressing fundamental economic problems where network neutrality arises.
No, but at least they give us an idea of how a network might be constructed, in the sense that, you know, there's a one network in North America, there's networks in every European nation state, and then there's Géant that glues them together. In other words, you actually have to construct these things. So I wasn't clear to me, you know, it seems like a POC would have the same kind of structure, that you would have some sort of national structures and some wider, let's say, European-wide structure on top of that. So
we were not thinking necessarily of having it along national structures. I think that we were presupposing, first of all, how to leverage sort of how you might set up an economic arrangement to leverage large scale leased lines. But I mean, you know, we even cite the Australian network as an example of, you know, we know that there are these nonprofit networks. We know how to manage them. We don't think that's, you know, breaking new ground. I think it is the scale of this and it actually sort of having a macroscopic impact on the overall economic organization of the internet.
okay. I mean, I like the idea of the POC. Why in your talk do you sort of say there's no BGP involved, for example? Because it seems like, you know, if you're going to build something today, you need a protocol to talk to other networks. Can you talk a little bit about that?
Right. So, I mean, there's no you know, on the POC itself and the LMPs that are connected to it, the POC runs some routing algorithm.
Right.
BGP probably wouldn't be your choice. There's no reason for policy on the.
Well, I mean, the educational networks, you know, Géant and Renater and all, they use BGP because you have to glue the thing together some way, and it's a way of isolating administrative domains. It's the only one we have today.
No, so precisely that
Yeah.
the POC is trying to say there are no administrative domains inside transit. Transit is not about administrative.
Okay, that helps clarify that.
So that's because you're absolutely, once you start getting administrative domains and the administrative domains have to reach agreements, then you start getting this cascading of a transitive peering arrangements, transitive BGP, and non-transitive value. And
Okay,
that's what we want to avoid.
I see, that helps clarify. We have one question here from Marino. He says, any size or specific property of internet ecosystems that would make more suitable for trying POC?
Nothing comes to mind. I mean, I think that the hope is that we can start reasonably small. This will, as some of the questions on this came up, you know, we refer to this in the paper as this is just a global IXP. I mean, we're not inventing anything new. What we're doing here is analyzing its impact on network neutrality and so forth. But I don't know where this would first take hold. I mean, I think I would interpret this question of if we were to build something like this, there are really two questions. Who's going to provide the bandwidth? And then who are the first LMPs who would sign up for it? And that second question is a really good one, and I don't know.
Okay.
Go ahead.
Yesterday, we had a question from Anya Feldman, which she basically pointed out that there are these nonprofit IXPs, exchange points all around the globe. Perhaps they could play some role in this development.
Yes, I mean, I think the goal would be that the POC would have terms of service, open peering. And as long as other networks were willing to sort of abide by that, they could attach. And so IXPs would be a natural extension of this.